Good evening, South Asian friends, and good morning, our European friends. I welcome you all for today's e-conference on hydrogen, the next clean energy, organized by Indian Chemical News, in short we call ICN, a credible and information-led media platform on chemical, petrochemical, and pharma sector. Myself, Praveen Prashant, editor Indian Chemical News, will be your host and moderator for today's conference. Today, we have got the entire hydrogen ecosystem stalwarts as speakers who will share interesting insights about hydrogen economy for the next 90 minutes. Let me give you a brief backgrounder. As of early 2021, over 30 countries have released hydrogen roadmaps, and governments worldwide have committed public funding in support of decarbonization through hydrogen technologies. No less than 228 large-scale projects have been announced along the value chain, with 85% located in Europe, Asia, and Australia. These include large-scale industrial usage and transport applications, integrated hydrogen economy infrastructure, and giga-scale production projects. If all announced projects come to fruition, total investments will reach more than $300 billion in spending through 2030. The number, which is very positive, is $300 billion in spending through 2030. Of this, $80 billion can currently be considered mature, meaning that these projects are in the planning stage, have passed a final investment decision, or under construction, already commissioned or operational. Deployment through clusters with strong off-takers will help suppliers share both investment and risk while establishing positive reinforcing loops. These three cluster types are already gaining traction, which is industrial centers that support refining, power generation, fertilizer, and steel production, export hubs in resource-rich countries, and port areas for fuel bunkering, port logistics, and transportation. Next slide. So the key discussion points for today's topic is green hydrogen strategy and roadmap, need for a favorable policy framework, developing a hydrogen economy ecosystem, India's advantageous position to adopt hydrogen, guidelines for corporates, establishing technology transfer partnerships, providing grant for R&D, pilots and upskilling, need for significant investment in electrolyzers, and storage, safety, and environmental concerns. The speakers for today's conference are Mr. P.V. Samudra, CEO and MD, ThyssenKrupp Industrial Solutions India, Mr. Sturle Harald Pedersen, Chairman, Greenstat Hydrogen India, Dr. Ashish Lele, Director, CSIR National Chemical Laboratory, Mr. Girish Shetty, Senior Fellow and Program Director, TERI, Dr. R.K. Malhotra, Director General, FIPI, Mr. D.M.R. Panda, GM Hydrogen Ntpc, Dr. Sushil S. Ramdasi, Deputy Director, ARAI, Mr. Siddharth R. Mayur, Founder, H2E Power Systems, Mr. Amit Singdev, Senior Managing Director, FTI Consulting. So let me give you a brief backgrounder about the list of events that we are doing in the month of April and May. On April 20, we have role of women in the growth of Indian chemical industry. On April 23, we have outlook and opportunities for the gas sector in India. On April 28, we are focusing on improving engineers with advanced analytics. On May 18, it is on Indian specialty chemicals opportunities galore. May 21, green chemistry and sustainability challenges and opportunities. So we have this ICN play and win contest. This is for the delegates. Just briefing you about the contest. The moderators will be asking questions from the audience during the course of the session, and the one who responds first with the correct answer stands eligible for winning rupees 1,000 gift voucher from Amazon. All the questions will be asked by the moderator of the session, and replies need to be given in the chat window. So one need to be careful that the replies need to be given in the chat window box of your respective screen on Zoom platform. Final winners to be announced at the close of the e-conference today at 4:30 p.m. Terms and conditions: only persons with the correct answer responding first in order for priority shall be declared winner. Organizers and sponsor partner employees are not eligible to participate in the contest. organizers' decisions to be treated as final in case of any discrepancies, and gift vouchers to be sent electronically to all the winners post completion of the session. So with this now, let me begin the panel discussion. The topic is hydrogen, the next clean energy. As we have already briefed, there will be 2 tracks of 3 to 4 minutes each. And in the last, we will have the Q&A sessions. So I would request my first speaker, Mr. P.D. Samudra. He's the CEO and MD of ThyssenKrupp Industrial Solutions India. Just a brief on ThyssenKrupp. Is a technology supplier, an EPC contractor, and has a very strong focus on hydrogen. So, sir, Mr. P.D. Samudra, how do you see the green hydrogen and what would be the strategy and roadmap for India? So over to Mr. P.D. Samudra.
Thank you, Praveen, and good afternoon to all the panelists and all the audience. It's an honor to be here. And I think all our experts and all the speakers know very well about the subject we're talking about. But maybe I can touch upon the basics to start with. After the Paris Protocol 2016, we all are committed to bring down the greenhouse gases emission to reach the level so as to bring the global warming well below 2 degrees centigrade by 2050. Presently, we are hovering around 0.9 to 1 degrees compared to the pre-industrial world. So we have to bring it below 2 degrees by 2050. And so we are committed to bring down the greenhouse gases. And all the nations have committed for that. They have to prepare plan and they have to discuss every year what actions they have taken. Now I come back to our own country where we have presently power generation of 374 gigawatt and there are plans to go to by the year 2030 something like 832,000 megawatt or 832 gigawatt. Presently we are having about 63% the power coming from the fossil fuel like coal and natural gas and stuff like that. Now that will change ultimately when you go to 2030, if you can reach that to the level of 35%, and the 60% power will come from the wind, solar and renewables and bio as well as hydro. Now to achieve this target and to meet the Paris Protocol requirement, we have to think of something which is going to be very, very revolutionary, and green hydrogen really comes in the way, comes in the direction of the proposed plan. So it is a buzzword now, and all of us are here to discuss that. Government of India rightfully made the policy, which has already been published, and there are now the plans are being talked about, and the demands for the hydrogen is supposed to go up by 10 times in next 5 years, and the investment, as Praveenji said, in India it will come to $44 billion as estimated. Now there is a shift taking place in the country, and a lot of industries like chemicals, refineries, petrochemicals, steel, transportation are supposed to shift out to green hydrogen. Now for this purpose, already you see that a lot of industries have come forward. You already heard that Ambani's, Reliance, Tata's, Mahindra's will work together for India's new hydrogen mission. IOCL, BPCL, GAIL are working on green hydrogen pilot plants. Adani is planning to go for a green hydrogen business. Mtpc is planning a pilot plant. Fertilizer, steel, petrochemical sectors may get a green hydrogen research mandate by the government. A number of companies are now preparing, doing research and studies on the green hydrogen. So there's going to be a massive shift in the big industries. But of course, everybody has to go cautiously. We have to first put up the pilot plan and to see the feasibility study, depending on the specific situation, how we can really come to the very economical cost of hydrogen, which is slated to be $2 per kg. And presently, we seem to be on the higher side. So that has to come to at least $2 per kg for the use into the power sector. And also government norms have to be modified to help that. So I'll touch upon two important topics here, that apart from all these big industries, the overall growth in the country in this direction can take place from the medium and a little bit bigger industries. So the smallest model could be at 20 megawatt, and there could be a cluster of industries to come to that level of hydrogen usage for generating the fuel for their own industry. Secondly, this is going to pave a big way for BOO operators. The build, own, and operate companies have tremendous opportunities to take out the investment on behalf of the customers, get the loan from the banks, and supply the hydrogen across the fence. So I think this particular strategy is going to benefit not only the industry, but the nation, as well as a lot of business people to make the BOO operation and supply hydrogen. So in all, we are poised for a very, very interesting phase in the coming years, and I'm sure this is the best way of going for meeting Paris Accord requirements. Praveen, that's what I want to say.
Thank you, Mr. Samudra. You brought a very good point that we should look at. There are two things which you brought: is how what we can say medium or small scale chemical industries and other industries can benefit by setting up 20 megawatt or so. And the other thing was the price, if it can be brought down to $2 per kg. So with these 2 points, now I come to Mr. Sturle Harald Pedersen. He's the chairman of Greenstat Hydrogen India. Just a brief on Greenstat. Greenstat is a Norwegian energy company with a specific focus on green hydrogen, solar, wind, and zero emissions maritime solutions. Good morning, sir. Thank you for joining all the way from Norway for this event. So
thank you very much.
My first question to you is, with establishing of technology transfer partnerships and providing grants for R&D pilots and upskilling, how do you see India as a market for all these with respect to hydrogen?
Well, thank you for the introduction and inviting me to this panel discussion. I'm delighted to and honored to be here today to participate and also talk about India's prospects. Greenstat, as you mentioned, was set up last year together with the Indian Hydrogen Cluster and its partners at the Center of Excellence in Hydrogen in India. And the vision for this was to set up a platform for transfer of technology and experience and know-how, which is crucial for India to be able to catch up with its neighbors, but also to become a leader in hydrogen. This center's main task was to provide the stakeholders, both in the public and the private sector, with a platform for cooperation, learning, and research and development projects. India, as I see it, do not need to reinvent the wheel. They can benefit from collaboration and participation at this center of excellence, together with the leading companies in the world for hydrogen. More than 160 companies are prepared and ready to go and work together in a partnership with Indian industries and government and research institutions. We have the leading universities and research institutions prepared and ready to enter into a partnership with the universities and research institutions in India. And we have already started several projects, which I will try to touch upon later. First of all, I would say it's critical for the government to formulate the right policy framework and plan for an adoption of the green hydrogen at the scale. The National Hydrogen Mission are in a process to launch a new policy and roadmap that I'm sure will include incentives and support for both R&D projects in the different sectors, but also to establish industry clusters, which I think is quite important if we are going to succeed in implementing the hydrogen economy in India. The government, in my view, needs to step up and participate with large funds in R&D activities to improve the current technology, focusing upon cost reduction, developing new material, quality and durability, also by reducing the maintenance cost in the value chain, and also to improve the energy efficiency. Government should also facilitate for more pilot projects in the different sectors to test the feasibility and the duration and the cost and risk for these pilot projects in the different sectors. But it can also be instrumental in training and capacity building, which is a key challenge when you are introducing a new industry and a new technology. So India today have a program, Make in India, and the hydrogen could be really a new area where you could create a lot of new jobs if the government facilitate for these concepts in the value chain. Through hydrogen demo projects and studies, improvements can be made to better perform of the technology at the larger projects. And Greens have, for this reason, initiated feasibility studies to set up minimum 2 pilot projects within the next 2 years in the maritime and the transport sector in India. And we are working together with Terry in one of them in Kolkata, but we have also a working relationship with several other companies in India to scale up R&D. And to in this effort, we have also joined hands with the Indian Oil, and our Center of Excellence is going to be located at the research centers in Delhi to work on CCS, CCUS, and fuel cells technology, and also other areas of improvement in the value chain. This is to reduce the cost and to accelerate the scale up of the transition to the hydrogen economy. And I believe that if we are going to achieve India's ambition, we need to work together. We need to bring everyone on the same page, because this is a tremendous task that no company by themselves, even the biggest one, can do by themselves. The infrastructure that we need to develop in India really demands a master plan where everybody participate and have a role to play. Thank you.
Thank you, sir. Good to hear that you have partnered with Terry as well as Indian Oil and trying to work on the CCS, CCUs and the fuel cell. Thank you. We will come back to you for the second round. In the meantime, I request Dr. Ashish Lele, Director, CSIR, National Chemical Laboratories, Pune. Congratulations, sir, for joining this institute recently, in this week itself. A very hearty congratulations from all the speakers as well as the delegates. Just a brief on National Chemical Laboratories, Pune. It is internationally known for its excellence in scientific research in chemistry and chemical engineering, as well as for its outstanding track record of industrial research involving partnerships with industry from concept to commercialization. So with this into background, with concept to commercialization, my question to you, Mr. Ashish Lele, is how R&D collaboration with corporate sectors will drive large-scale projects in the hydrogen economy. So over to Mr. Ashish Lele.
Thank you, Praveen. It's my pleasure to be here. A real honor to be part of this conversation, and good to see many friends on the panelist, Sturle, Malhotra ji. Good to see you again. So, Praveen, I think first of all, let me just quickly tell you that CSIR, which is the parent organization of where I belong, has been in the area of hydrogen for many years. We have a special purpose vehicle called the Mtpc program, which was started back in 2002 under the leadership of Dr. Mashirka at that time, which is a very interesting program, very technology focused, and is intended to take technologies developed in the labs to commercialization in close cooperation with the corporate. In that program, we have been running a program on fuel cell development and electrolyzer development technologies. So this is more to understand the nitty-gritties of the technology, the fine level details of these technologies. And we've been running this for about 7 or 8 years. So we've looked at both high temperature and low temperature electrochemical devices in both these areas. And one of the outcomes of this, there are 2 or 3 major outcomes that I want to highlight. One that made a bit of news in the recent past, last year, was the first hydrogen-powered fuel cell car that was demonstrated on the campus of our laboratory. That was in partnership with a company called KPIT. And that was a 10 kilowatt fuel cell, which was totally indigenously developed, our own design, our own materials, our own assembly, full integration of the fuel cell with the rest of the components of the drivetrain. So basically, just to let you know that we're not only looking at materials research, but taking it all the way to component level research, subsystem level research, as well as full system level research, so that the final end-to-end technology gets demonstrated. That technology is being, this progress is made further, and our intention ultimately is to go to heavy-duty vehicles, because as Churle also said, that is one of the key applications for hydrogen in India as we see it. So in this picture, the role of R&D is very important. I completely agree with what Sturle said, that there is no need to really reinvent the wheel. One of the reasons why hydrogen ecosystem today has caught a lot of attention, as we all know, hydrogen went through several hypes in the past, but this time it looks like the hype is for real. And one of the key reasons for that is the fact that technologies across the entire value chain, from hydrogen generation to hydrogen utilization, is now very robust, is very mature. There are players who are scaling the technology up, therefore costs are coming down. And therefore, from the technology maturity, the higher TRL levels, many of them reaching even 9, 10 TRL levels, to actually large scale production of the technologies, is really what is making the hydrogen technologies across the value chain more and more viable. And that's why we believe that this interest in hydrogen, which is exponentially growing today, is real, and it's not just a hype. In this context, therefore, the role of R&D needs to be looked at carefully. And in India, again, I'm in full agreement with what Sturle said. We need to do a lot of value engineering of products as they come to India. While the technologies are available outside India, it is, one can't really say that they will be ready for implementation under the Indian conditions of whether it is the drive cycles or the climatic conditions, the geographical diversity, and many things, right? So one has to adapt many of those technologies to suit Indian conditions, and that will require some amount of value engineering, and that's an important role that R&D would be able to play, in my opinion. That would then also result into cost reduction, both in terms of capex reduction and opex reduction. Opex reduction clearly in terms of improving efficiencies, which will be linked to the material availability, the supply chain for materials, and so on. As well as the improvement in durability. And this is very important because Indian climatic conditions are certainly very different than outside. The air qualities are very different than outside. And so durability of a product that is tested in Europe and US or Japan is not necessarily guaranteed in India. So that kind of cost optimization, durability improvement, material supply chain, careful look at it, all of that is part of the things that R&D can certainly contribute to. The other thing that R&D can really help is with vendor development, and this is under the Atmanirbhar program that the government has launched. Many of these electrochemical technologies is made up of multiple components, and these multiple components require many vendors. So the local manufacturing would require a lot of vendor development, and as Turle also said, that means a lot of job creation. Okay, so that vendor development part, the understanding of the technologies, the assimilation of those technologies and translating it into vendor development is a very critical role that I believe R&D can play. Finally, capacity building. A lot of training will have to be required. The R&D can play a big role in training the workforce all the way through and through the value chain. And lastly, R&D can play a big role in establishing standards and codes and certification processes. Many of those are established outside India. They need to be translated, re-looked at, and rewritten for the Indian context. And there we need experts, and I believe those experts, R&D can contribute, the R&D institutions can contribute in a big way. Finally, I'd just like to say that CSIR is taking a world view of this, but with focus on India. And it is our intention to set up a center of excellence within the CSIR framework, and we will be happy to participate in other centers of excellence. One that Churle mentioned. We want to also engage with the corporate sector. We are already working closely with some of them, but we want to build on our engagement. And that is what we believe, R&D institutions can do, and in particular, what CSIR and NCL can do. So thank you for this opportunity, and I will stop here.
Thank you, Dr. Ashish Lele, for your views. Now I would request Mr. Girish Sethi, Senior Fellow and Program Director, TERI. TERI has been doing a lot of analytical research on hydrogen in a big way, and I would request him if he can talk about how he can develop the hydrogen economy ecosystem. So over to Mr. Girish Sethi.
Yeah, thank you, Mr. Praveen, for this opportunity. Let me mention at the start, when we talk about the overall ecosystem for hydrogen, one probably would like to see it from both the perspectives, from the perspective of the supply of hydrogen, and then also from the perspective of the demand for hydrogen. And as I think my predecessor in the previous speaker, Mr. Ashish Lele, he mentioned that hydrogen is not something new. It has been around for many, many years. And there have been ups and lows in the past on the subject in terms of the hype. But I think I would fully agree with what he mentioned, that this time perhaps the hype is real. And for many, many reasons, I think. And one of the reasons which I believe, and we at TERI believe, is that, yes, there is a real interest now from the demand side as well coming up, because of the many favorable factors which are influencing the subject of green hydrogen. I think there are many speakers in this audience. I think people who must be knowing that India has been working at the government level on R&D side and everything for many, many years on hydrogen. But somehow that offtake has not been there. But at the same time, we have seen the use of hydrogen in India. The fertilizer industry, the chemical industry, the refineries have been using hydrogen for many years, but of course that hydrogen has been coming from the steam methane reforming route. But when one is now talking about the use of green hydrogen, I think all over the Europe and elsewhere, I think that's where the interest lies. So we, as you mentioned, I think we at TERI did a very, very detailed analysis last year on the role of potential role of hydrogen in India, and we released a report in the month of December, which actually talked about this whole subject of the whole ecosystem of hydrogen. And we clearly brought out that the analysis, which clearly brought out that there is definitely a chance of at least 5 to 6-fold increase in the requirement of hydrogen from the present level of around 5 to 6 million tons up to around at least 30 to 40 million tons by the middle of this century. And the primary driver, what we feel actually will be the industry sector in this whole demand. We believe that almost 75 to 80% of this demand in the next 20 to 30 years would actually be coming from the industry sector, and that would be led by the steel sector. We know that the steel industry in India is today around maybe around 110 million tons of steel, and the national steel policy in India talked about almost tripling the total capacity by 2030. So even if we assume that we will be around 2050, so 2.5 times the present capacity in the next 10 years, and by the estimated demand of around close to around 450 or 500 million tons in that range by the middle of the century. So steel industry is going to really lead this way, because if one is going to move towards low carbon steels, and with the entire background on the Paris Accord and reaching 1.5 degrees centigrade. So I think that's one area where one will have to invest a lot in terms of the developing the use side of hydrogen. Of course, the demand from ammonia sector, from refineries will continue. But I think we believe that with the costs coming down of hydrogen in the coming decades, as was pointed out, we also brought our analysis that it would be around, once it comes to around $2 per kg, it can easily compete with the existing options. So even sectors like ammonia and refineries can find it attractive to move towards green hydrogen from the electrolysis route. And just to mention, I think we in India talk about electrolysis of hydrogen as something relatively new, of course, but the fact is that if one remembers many, many years back, I think the first plant in India in Punjab, in Bhakra Dangal, for manufacturing the, for the production of urea in there was actually based on the electrolysis of water. Was at that time electricity was in surplus, and of course they moved on to something else. But we do have an experience of working on hydrogen in India in all the sectors. So that is on the use side. But I think if one looks at, there are other areas also where one has to really start looking at it. I think the use of hydrogen for industrial heat in many cases, of course, a lot more research is needed to do the, find the use case applications. I know of how the research is happening, the feasibility studies in UK, where they are looking at the HyNet project of how it can be used in furnaces and in glass making and things like that. And then, of course, the use in the transport sector is there. But on the supply side, I think not just the production, but I think the importance would be also looking at the storage area, transportation of hydrogen. And I think, again, as the capacities ramp up in terms of hydrogen, the whole subject which you referred to in your introductory remarks about the clusters of industries using and sharing the entire infrastructure for hydrogen, that would be the key in taking the whole thing forward. And on storage, let me also mention, I think there is also a need for us to really start working on and looking at what are the options for storage in big, because in many places they are talking about rock storage and also, but here I think the steel structures in India would really be something, because there's hardly any research which has gone, or research or maybe I think analysis which has gone on the availability of the low cost rock cavern storages. So this is broadly on the overall demand and supply side, but I think what I would like to say that with the hydrogen mission being announced, I think in India that really paves the way for all the actors to really come together and start looking at this in a real way, so that this hype which was mentioned by Ashish, that is really harnessed in a real positive way. So that's all from my side.
With respect to the need for a policy framework in the second track, thank you for your views. Now I request Dr. R.K. Malhotra, Director General FIPI. FIPI stands for Federation of Indian Petroleum Industry. He also wears a hat of Hydrogen Association of India, which is promoting, increasing, encouraging and developing the growth of hydrogen energy and its application in the country. So I request Dr. Malhotra, sir, if you can talk about what would be the need for a policy framework so that hydrogen economy can come to, as experts say, to $2 per kg, so that it can be deployed to different applications that people have been talking about. So over to Dr. R.K. Malhotra ji.
Thank you, Praveen, for inviting and giving me an opportunity to share some of my thoughts with this audience, and also the distinguished panelists. It's a pleasure to be sharing this panel with some of the good friends like Dr. Ashish Lele. I only today learned that he has joined as director in the National Chemical Laboratory. So my congratulations to you, Dr. Lele. And also good friend Siddharth, with whom I've interacted a few times. I've heard about Mr. Sturle, that the Association of the Center of Excellence, which he's going to have with IOC R&D. For your information, Mr. Sturle, I was the director R&D in charge of, I worked there for 37 years and retired a few years back before taking up this position. And it was a pleasure to start some of the hydrogen research activities during my tenure there. In fact, the first hydrogen dispensing station in India was set up in our R&D way back, about more than 10 years back. And we had also established a Hydrogen Association of India. Now, Praveen said that I should be talking about policy. So what we had thought at that point of time was that, as Mr. Lele said, that hydrogen has come up several times and gone, and the interest, but now this time the interest seems to be real. But at that time also, we had started working. I had visualized that it has a future, and at some point of time, our organizations like oil and gas companies will have to think in terms of transforming themselves into energy companies, and we'll have to look at hydrogen. Many of my colleagues at that time questioned my wisdom on working on hydrogen and on bioenergy. They said, hydrogen is far off. I said, but my duty as the in charge of R&D is to prepare the organization for future. So I'm glad that things are taking shape. Hydrogen, CNG, which we started, is now getting commercialized. At that time also, I had, on the policy side, we had worked with the Ministry of New and Renewable Energy. Ministry of Petroleum and Natural Gas had also set up some task force, etc., where we had developed some of the reports on the production side, storage side, transportation options, delivery options, and safety codes and standards, and the utilization side. Now, of course, now the understanding is much larger. During last 1 year, people have gathered more information on hydrogen, and people are now more wiser. And Praveen talked about bringing down the cost to $2 a kg. Somebody mentioned earlier also. Whether that happens 2 or 3, but ultimately, I know that the cost of transporting hydrogen and delivering hydrogen is sometimes even more than the cost of producing hydrogen. So I think the overall, we will have to see in totality how much the customer has to pay or the consumer has to pay. That should be reasonable and must be comparable with the other forms of energy which he is using. Now, you have started talking about green hydrogen in this conference also, you said. But I personally believe that green hydrogen, we are growing very fast in renewables, no doubt about it. But whether we will have so much of renewable energy that we can stop the coal-based power generation, I have my doubts. For next 20 years. We cannot afford to do that in India. We have large reserves of coal. And even if we do that, somebody said 35% or 40% will happen, but still 40 to 60, more than 50% will be coming from thermal power based, whether it is coming from coal-based power or natural gas-based power. So if we use that, then, to think that we will convert the renewable power rather than using it as power, electricity, we will convert it into hydrogen. Certainly that's correct, but it should be, in my view, hydrogen should be the storage media. It is not an energy per se. It is a medium of energy transformation. So hydrogen can be used as a storage media whenever you are not able to use that solar power or wind power and convert that. And my good friend Siddharth, his company H2E, has got reversible type of SOFC technology or SOEC technology, let me say so. I think he will certainly throw more light. Siddharth, you please do that. That for distributed power generation in villages where you can, have more of renewable power generated, or in the coastline which we have, you convert that when you are not using into hydrogen and then convert back into electricity and use it. Oh, that's fine. But if you want to use hydrogen in the industry, I think the blue hydrogen will find much larger space in India, in my personal view. Companies like Indian Oil, Reliance, and all majors, if we partly, stop producing electricity from coal-based, or it goes down, you can have coal gasification units. And as Mr. Sturle said, that CCUS technology or CCS, etc., you will have sufficient technologies for carbon to chemicals developed in next few years. I think the blue hydrogen, once you have done that, if you can capture carbon and convert to chemicals, they are not emitting any carbon, then there is a problem of creating any pollution or any CO2 emissions. Or somebody mentioned about meeting the INDC targets or global mission of reducing carbon emissions, etc. So blue hydrogen, in my view, will complement green hydrogen. And I will bet more on blue hydrogen because our refineries are well placed to do it. Reliance has got big petcoke gasification units. While I was at IUC R&D, we had developed a patented technology where you could use the coal, petcoke, and biomass and do a co-gasification together of them. Indian coal has more of ash. So the problem solution which we had found was that if you can use partly biomass, you can partly use petcoke, you can have good gasification and you can produce hydrogen or even produce chemicals, etc. So I think blue hydrogen will continue to play a much larger role in India in next at least 15, 20 years. Green hydrogen, yes, well, wherever you have so much of surplus renewable power, you can always convert it into. And biomass in renewable power will also find a very prominent space rather than only solar and wind. So I think all this will help us in moving towards hydrogen economy in much faster way. Oil and gas companies are well positioned. They know how to handle hydrogen in refineries. We are the largest producers and consumers of hydrogen in the refineries. So we know how to play with hydrogen, how to transport hydrogen, how to play it safely. So if we have to move to hydrogen economy, you cannot downplay the role of the oil and gas industry and the blue hydrogen in future or even gray at this point of time, and through coal gasification, etc. And depend only on green hydrogen if you have to have hydrogen economy in India. So I think on policy front, we have to be very clear and we have to not say only green hydrogen, we have to say the other forms of hydrogen also. Because ultimately, it will be, if you are using it in transport fuel cells, you are using it much more efficiently, because the fuel cells in transport sector will be 2 times more efficient than the internal combustion engines. So if you, the overall energy consumption will go down. So once the overall energy consumption goes down, the CO2 emissions go down. So I feel that the hydrogen should be considered in all forms. When we have to move to hydrogen economy, okay, you can keep a target of moving ultimately towards green hydrogen once you have sufficient renewable power available. Otherwise, till such time, we from the oil and gas industry are well positioned to supply enough hydrogen, which are in the form of grain for the time being. And once the technologies on CCUS and CCS, etc., where scientists like Mr. Lele and the organizations like Mr. Sturle, who are creating center of excellence, will certainly be ready in next couple of years with those kind of technologies. And blue hydrogen will have no issues connected with carbon emissions, and that can be utilized. So these are my initial views.
Thank you, sir, for very elaborately explaining how the hydrogen economy will move as we move forward with your experience in Indian Oil and also in the R&D sector where you have worked very extensively. Now I would request Mr. DMR Panda, GM Hydrogen NTPC. NTPC is looking at green hydrogen, is also looking at battery storage to drive energy transition as moving from coal-based projects. The company is planning a tender for what we can say hydrogen vehicles for pilot in New Delhi and Leh. So a lot of automobile companies, as well as for its own power requirement also, everybody is looking at NTPC in a big way. So my first question to Mr. DMR Panda is, what would be the role of NTPC in promoting hydrogen in India with respect to transport, with respect to industry, and with respect to power? So over to Mr. DMR Panda.
Yeah, thank you so much. And I really think it is a unique chance to offer NTPC's views to the media, to all the participants who are listening and watching this proceedings. First is that the NTPC believes that green hydrogen should be the solution, and it is partly philosophical, partly scientific, partly art, but eventually we feel that this has to be green hydrogen, which means that we need to have enough renewable power. Now within NTPC we have a plan to add 60 gigawatt of renewable power in next 11 to 12 years. And all of us know that the government of India is planning for 450 gigawatt of renewable power. And we also know that India's power requirement may not be that high, given that many of the investments in existing coal power plants have not reached a stage where they can be abandoned. The point is, if we have enough renewable power, what I do with that, like one of our esteemed panelists observed that hydrogen should be the storage, energy storage. Now, I will just go further. If I restate Ntpc's stand on this. Now, we want to have all existing power plants wherever possible as a chemical complex. Earlier, it was a power complex. Now, it's a chemical complex. We'll be making green chemicals. We'll be making hub of production of hydrogen, and so on and so forth. Now, within Ntpc, we have been making hydrogen from electricity for last 40 years. Because for the hydrogen use in power plant, probably some of you might be knowing that in the generator for cooling those high capacity generators, 200 to 800 megawatt, all are hydrogen cooled. So we need enough hydrogen to be produced, and the most favored way of making this is electrolysis. So we are not new to that. But the point is that all the pilot projects that Ntpc is wanting to take, I will elaborate those, that we need huge quantity of hydrogen, green hydrogen to be precise. Now, what is the cost of having that? Now, to give you some idea, our moderator mentioned that Ntpc is planning to have fuel cell buses in Leh and Delhi. So we need renewable power, we need then green hydrogen, and the costs are of course prohibitive. So then somebody needs to fund it. Now whether Ntpc will do, Government of India will do, or from some source, and how long? Like we have been reading all these things in the media that in other countries, when the funding dried up, people simply abandoned the hydrogen buses on the roadside, because the more they run, the more losses they would incur. That's the world view. Now, in Ntpc, what we are trying to do? So first is, of course, green mobility in form of hydrogen buses, microgrid, specifically for those locations where we do not have a stable or presence of any grid at all. So of course, one or two things comes to our mind in Ladakh, here in Andaman and Lakshadweep. Now, how they are managing? So they are heavily dependent on diesel. And to all these places, when the diesel goes, of course, the prices go up, leave aside the pollution part. And when we are focusing so much on decarbonization, now this need to be replaced. One of the possible way is then and there make green power, green hydrogen, and try to do all that we can do with green hydrogen. Then we are launching pilot projects on green methanol in 2 of the power plants. The objective is to extract carbon dioxide from the flue gases, which comes by coal burning, add green hydrogen in a suitable reactor, and then we have green methanol. It is easier said than done. It's a complex process, as all of you know, but this has to be done. And similar is the way we'll have to make green ammonia, that is in the planning. Last, that we need to have hydrogen blending into the natural gas. Right now in India, we have city gas distribution systems, many of the major cities. So, and this gas, natural gas, is only utilized for burning, which means cooking. Now, since it is for burning, if I mix some percentage of hydrogen into that, then I'll be saving on carbon, one. and then the user will not feel any difference in the cooking. That is one. And then, of course, micro CHPs or simple CHPs for heating, because anybody who is into hydrogen knows that the fuel cells, whether it is alkyl or PEM or SOEC, makes as much heat as electricity. So this heat, why to throw into the atmosphere? If it can be utilized for heating, that's great. So this is what NTPC has been doing, different pilot projects. So 6 of them are there. And our cornerstone is green hydrogen. Enabling thing is our renewable power.
So we'll come back to you, sir, with respect to the challenges and expectation from the industry, which needs to be featured. Now, thank you, sir. And now I request Dr. Sushil S. Ramdasi, Deputy Director, ARI, which is Automotive Research Association of India. ARI is the leading automotive R&D organization in the country, set up by the automotive industry with the Government of India. It is a prime testing and certification agency. So the first question to Dr. Sushil S. Ramdasi is, what are the real challenges while increasing footprint of hydrogen-based e-mobility? So over to Mr. Sushil S. Ramdasi. Sir, if you can unmute yourself.
So thank you, Mr. Praveen, and good afternoon to all. So first of all, I would like to thank ICN and Mr. Praveen Prashant in particular for arranging such kind of a virtual event on a very important topic. Okay, as you asked, what are the main challenges while transforming from a conventional powertrain technology into an e-mobility kind of powertrain technology which is coming up? Okay, so let's go step by step. So as everybody knows that Government of India has leapfrogged from BS4 to BS6. We have skipped BS5. And now practically all OEMs are ready with BS6 technology, whether it is a gasoline or diesel. So looking at the reduction in the particulate matters and NOx, especially from BS4 to BS6, we have almost reduced by 60%. But still the major challenge is there. Still major question is unanswered. That is, what about CO2 emissions? With incorporation of all high kind of after treatment devices, fuel injection systems, or even turbocharging technology, even the engines have gone downsized, downspeeded, etc. The CO2 still is above 100 grams per kilometer. That is the number one. Now, in order to bring that CO2 less than 100 grams per kilometer, we have to now change the technology rather than upgrade the technology. IC engines are there for more than 100 years. Same thing is there, piston is there, conrod, crankshaft. We have optimized it. And now practically it is touching now to a very, what I can say, a saturation level. Diesel engines have reached practically to the thermal efficiency of around 38% to 40%. Okay, that's why we require a change in technology, and that will come in the form of e-mobility. And when we say e-mobility, we have now 3 different options. Which option we should select? It depends upon the country's policy, country's roadmap, and the people's, the end customers' acceptability. That is very, very important. Okay. So from Indian perspectives, while doing this transformation smoothly from e-mobility, from conventional powertrain to a hydrogen-based mobility. So let's go step by step. We have talked about conventional powertrain. We have reached up to Euro 6. Now, in our opinion, we should start with the hybrid electric vehicle as a first option. And we should not look for a very complex kind of hybrid technology which will give 35% fuel economy. Even if you go with a low cost, full parallel hybrid or strong hybrids, which will give you a 20%, okay, that will give a life to the IC engines. And those IC engines then cannot be only a diesel power, it can be a gasoline, or even it can be alternate fuels like CNG, now E20 is coming, or even some percentage of 15% of methanol. So all those experiments, you can do it with the IC engine, but you should do it with the electrification so that you can meet Euro 7 and above, and the CO2 emissions will further come down. This will also give you time to increase penetration of electric drive related technologies like motors, power electronics, batteries. So the cost So the volume will increase, cost will go down. Yes. Then you should switch over to a pure electric vehicles slowly, because by that time the technology is mature, cost has gone down. But that segment you should start with the public transportation first, or public carrying vehicles like three-wheelers or intercity buses. Then the final destination should be a hydrogen-based fuel cell electric vehicle. Now let's focus only on this, because the focus is today's focus is on particularly on the hydrogen. Now, from our perspectives, while doing this transformation from conventional powertrain through hydrogen, through hybrids, electric, we should focus mainly three areas: small commercial vehicles, then heavy commercial vehicles, and intercity bus applications. And fourth, I will touch upon even tractors also. So let's talk one by one. So heavy commercial vehicles or bus, you require a longer range, especially intercity. There are buses traveling 500 kilometers, 800 kilometers. So you cannot carry such a huge battery. You have to stop at somewhere, at least minimum 3 to 4 hours you have to spend in charging. That falls exactly where the implementation of hydrogen fuel cell, it finds its own importance. So it is true for a bus application, or it is applicable for heavy commercial vehicle application. When you talk about small commercial vehicles, you can use all these SCVs or three-wheelers in the form of electric vehicles. And then instead of depending on charging infrastructure, you can have onboard range extenders. So it can be, if it is up to 10 kilowatts, it can be a PEM, or even it can be a solid oxide based fuel cells. I think Mr. Mayur can throw some light on this solid oxide based fuel cell technology as a range extender for three-wheelers, passenger car, and small commercial vehicles. And we find tractor also is a very good attractive segment now coming, because the government of India is pushing to use bio-waste and bioenergy. So we can create local clusters to generate hydrogens, as Dr. R.K. Malhotra absolutely, he correctly said that, yes, we should target for the green hydrogen, but we should not constrain to that. We should start penetrating the technology by using blue hydrogen. And while doing this, the major challenge is the capex. On OPEX front, all refineries have taken a lot of efforts instead of in making hydrogen, storing hydrogen, transporting hydrogen. But the major problem is, what is the cost of fuel cell? What is the cost of the electrolyzer? Still, it is $500 per kilowatt. How you can bring it down? And then only the OEMs can make a viable business case. The second one, the cost of hydrogen storage technology. The segment what I talked, it requires minimum type 3 cylinder or type 4 cylinder. And cost of those cylinders, still it's imported technology, very, very high. So there is a huge potential, okay, to reduce this capex by focusing on the fuel cell technology and hydrogen technology. Parallelly, whatever efforts are going in hydrogen formation, storage, and transportation. So I think these are the major challenges. If we address this, then the electric vehicles will get rather more life, more range, okay, through means of hydrogen. So hydrogen fuel cell vehicles are basically electric vehicles, and they are going to become a complementary.
So we will come back to you with the second part, sir. In the meanwhile, let me open the ICN Play and Win contest. And the first question to all our delegates is, and I would request to type their answers on the chat window box of Zoom platform. Investment in hydrogen economy will reach $- dash in spending through 2030. I repeat, investment in hydrogen economy will reach $- dash in spending through 2030. Please type in your answers. So thank you. And now moving ahead, we have another two speakers. We have already reached 4 o'clock. So we will have to speed fast. We have Mr. Siddharth R. Mayur, founder, president, and CEO, S2E Power Systems. And I liked his, what we can say, caption, which says, Swadeshi Urja for Swavlambi Bharat. And the core philosophy of S2E is based on the foundation of helping every individual become energy independent and secure using clean and green technologies. So Siddharth, if you can talk about the different use cases, you have been working with different companies in different geographies. So if you can elaborate on it. Over to Mr. Siddharth Mayur.
Thank you, Praveen, for giving me this opportunity. You have a very vibrant audience. You announced the quiz, and I think 62 people have already replied. So,
One more thing is that we had around 695 people had registered for our event. We had already passed 300 at say 15 minutes back. We are presently at 284 concurrent participants who are on our platform live. Over to Mr. Siddharth.
So it is not just Bill Gates, Jeff Bezos, Mr. Ambani, Mr. Adani, the NTPCs and IOCLs of the world. It is the people on the ground. And therefore, hydrogen story is for sure and for real this time. So coming to a lot of interesting topics have been covered by the esteemed speakers on the panel. And I think a few, I would pick a few of these topics and talk about use cases and also what H2E is trying to do in India. The topic of R&D that Dr. Ashish Lele mentioned, and it's very, very important. We have been following that line, and I think my hydrogen journey started with the interaction with Dr. Ashish Lele. I think it was way back in 2012 or 11, I believe. So we've been working on this entire ecosystem of developing vendor base, developing components in India, and very happy to say that we've been able to build an ecosystem which will enable us to build a 98% made in India product by the end of 2022. And I'm talking about every nut bolt, every the interconnect plate or any component going in. And that is, I think, the fundamental task about bringing this whole hydrogen story to play. Coming to where you generate hydrogen and then the use cases, Dr. Malhotra ji mentioned in his address that we should also look at biogas or the waste. The amount of waste that India generates is probably enough for India to have surplus hydrogen that we can sell it to the world. So this is green hydrogen is good, you know, coming from solar, coming from wind. But that again, we have to realize these are intermittent sources. The bio waste is a permanent source. I can have a biogas plant run 24/7. Every Indian produces 600 grams of bio waste per day. We're talking 123 crore Indians. So India definitely missed out on the Google race. You know, we couldn't make a Google or we couldn't make a Facebook. We also lost out on the DNA race. In the post-COVID world, though, India is making headlines and is leading the race on the COVID vaccine. I think India is leading the race. And I personally believe that India can lead the race on hydrogen as well. And that's one of the reasons why we as a company invested into this process way back in 2009. That's when we started working on the entire ecosystem. And the ecosystem was not just to import a product out of Europe or the United States, but to build something which is local, to build something which is real and build something that is possible in India. And because we are a startup company, we are a first generation company, we had the choice to choose the technology that we go into. And we went into the solid oxide technology because everything that is in solid oxide can be made in India. No precious metals, no high value chemicals or rare earth chemicals involved with it. And while in the journey, we definitely work on PEM, we work on alkaline, we also work on the bio waste. Building on these, we've built an organization which I think one of the panelists also mentioned about scale. Dr. Pedersen also mentioned about clubbing together technologies from different parts of the world. So we brought Europe into India and India into Europe, you know, working both ways. And we've built a scale. We are building a gigawatt factory. I think not many of you know about this. We've still been working in a stealth mode. Pune will see a gigawatt facility on hydrogen fuel cells, producing electrolyzers as well as fuel cells by end of 2022. Another less publicized fact about H2E is my office and my facility is running on green hydrogen and bio-CNG based fuel cells for the last 2 years. We are not using the grid. So we are a real test case. We've built a microgrid, we've built a mini grid already in our facility here. The use cases, India is a large country and we have different problems. But if you're looking at the world at large, we are talking about 51 billion tons of carbon that we emit in the world. And I think Mr. Samudra mentioned in his opening address that 2 degrees has been what was agreed in Paris. That 2 degrees has been reduced to 1.5 already. And we are fast approaching that target. Pune today is 42 degrees, which is unheard of. So 51 billion ton is what we have to deal with. So net zero is the target. It is not about reducing the carbon. We have to bring it to zero. How do you do that? We have to look at different cases. Whether it is, I can go to green hydrogen and reduce it to zero, which is ideal case scenario. But is it going to happen tomorrow morning? It is not. We are talking 2030, 2040. So in the interim, we have to look at decarbonization, and then we have to look at defuelization. So taking hydrogen as a product, which becomes your singular fuel, then we move on to green ammonia, as Dr. Panda mentioned. We move on to methanol. And these are the beautiful things that the whole fuel cell technology can do. For example, the solid oxide electrolyzers are with co-electrolyzers. So you can make green ammonia, you can make syngas. From syngas, you can make methanol, diesel, kerosene. So there are multiple things that you can do with the hydrogen as a base technology. So moving into mobility, a lot of speakers have spoken about mobility, and mobility is, I think, a very romantic subject worldwide. People, all of us drive cars and all of us love flashy cars. So that becomes something that we immediately have an affinity to, especially with men and boys. These are the toys that we love. But I would get into a different topic, which is a little unglamorous topic. That is the food value chain, agriculture. 118 million farmers in this country who are cultivators of land which is less than 2 hectares. How about converting each of these farm into a factory? How about giving them 24/7 energy independence? And that can be done by the whole hydrogen ecosystem. So creating small biogas plants or creating small electrolyzers. I'm a big fan of the distributed power story. I always talk about kilowatts. I never talk about gigawatt scale. How about every farmer having a 2 kilowatt electrolyzer where he's producing hydrogen enough that is required to convert his farm into a completely mechanized facility. Use a fuel cell, give them power 24/7. No distribution losses, no T&D losses, and he's the controller of his own destiny. Just one experiment we did on a sugarcane farm for 3 months in Pune district in Baramati area. On 1 acre, we were able to save 25,000 liters of water per month. It is not that we did any magic. It is just because they had power available 24/7. They were able to utilize the water in a very effective manner. We were able to increase productivity by 35% on a 3-month basis. And the farmer, though he gets free power in Maharashtra, he said that he would be more than happy to pay us for the power because he weighed the gains where this is going. And we are looking at 450,000 villages in India. How about getting all these farmers collected? How about creating mini grids and micro grids into the village using hydrogen coming out of bio waste or coming out of agriculture waste or coming out of renewables? So we are a big fan of this entire concept, and H2E is very actively working on this entire process. We've developed a system, we call it the Urja Rath, and it's a trailer which goes to every farm, every home, which gives these people opportunity to uplift themselves. And these are the people who can pay the money. We generally feel that the agriculture economy cannot pay, but our experience has been that they can pay big money. And agriculture, again, is almost 20% responsible for the entire carbon emission. Dr. Ramdasi mentioned about a fuel cell tractor. So we are working on something with ARAI, ideating on how we can use a methanol reformer and produce that. So why only hydrogen? Somebody spoke about hydrogen storage. H2E is heavily invested into the reformation technology. We are working on methanol. We are also working on diesel. Who says diesel is bad? If diesel is going to not emit CO, NOx, POX, particulate matter, if the CO2 is going to come down by 60%, I think that's a very good story on a tank to wheel or even well to wheel story. So working on these processes will give us a better and a cleaner environment while we move towards the greener environment. So agriculture is one part. The other part is the combined cold heat and power segment, where I see a big potential. H2E currently is operating CHP systems in 800 homes in Germany. We are going to install another 3,000 systems in Germany and Switzerland in the next 2 years. We are also bringing these technologies to India, where every home will become energy independent, where every home will become a power producer of their own. Then moving into the whole crypto side, where the homeowner can actually start making money out of what they're producing. So utilization of heat, I think Dr. Panda mentioned about that. We are taking that heat and we are converting it into cold water. So you're taking care of the HFCs and CFCs your air conditioner emits. This is something that nobody talks about, but the most poisonous of the greenhouse gases. Of course, CO2 has a longer life, therefore we all know CO2 as a bad gas. But the immediate spike that comes is from methane, that spike that comes from the HFCs and CFCs. So how about reducing those? How about reducing the utilization of energy required for heating and air conditioning? So I'm reducing your bill by almost 50% because these are the energy guzzlers. So the combined cold heat and power market in India, Pune produces 78,000 new homes per year. India produces millions of those. So if we can get every home, and we start with ourselves, Praveen, if you become net zero, if your home becomes net zero, your society becomes net zero, your county, your community, your city, district, state, country. So, if we take this pledge to go net zero, that is where the big story lies. And that's where the big jobs are going to come. That's where the earth is going to survive. And people talk about leaving a better earth for our children. I also want to live here. I still have about 30, 40 years of life left in me. So we have to build this planet for us. And
back to you.
Yes, just the last point I will make.
Yes.
The industrial sector, again, is a big use case for the whole hydrogen story. Look at the oil and gas sector. We look at process sectors where you use process heat. So you can use the waste heat that is coming out of fuel cells and hydrogen. The iron and steel industry, which is the lowest hanging fruit, where I can immediately replace the pet coke and replace that with hydrogen. And also the cement industry, where you do the CCU, CCS, and produce a cleaner planet for all of us to live in. So I will stop here because of paucity of time, and we can take in questions. Thank you.
Thank you, Siddharth. Now I request Amrit Singh Dev, Senior Managing Director, FTI Consulting. Brief on FTI Consulting is an independent global business advisory firm dedicated to helping organizations manage change, mitigate risk, and resolve disputes, financial, legal, operational, political, and regulatory, reputational, and transactional. So my first question to Amrit is, how do we develop this hydrogen ecosystem, and how do we take care of the supply chain ecosystem? We are already in the first round, so we need to be fast, and we also need to take up questions. So I would request Amrit if you can help me in that direction. Over to Amrit Singh Dev.
Thank you, Praveen. So I know there's been a lot of work being done actually over the last 15 years, right, in India, and the speakers have all referred to all the R&D momentum that's been built. We wouldn't be having a discussion today if all those projects hadn't happened, or those R&D efforts are not underway. But also, I think it's also a moment to reflect on what we have achieved till now. We've achieved quite a bit as a country, but we're also seeing that outside the country, as in Europe, Japan, Korea, which have come relatively newer, they are taking different approaches as well. Some are building it out on the back of infrastructure, but what is common in at least Europe, Japan, and Korea is they're looking at the value chain in its entirety and looking at industrial, as in hydrogen valleys, as they are calling it, right, which is a cluster approach, but at scale. So how do we move from R&D stage to large scale demonstration projects? That is going to determine the volumes and bring down costs, because as you would have heard from every speaker, economics is the reason why we will not be able to hit some of the numbers that we are putting out for ourselves as ambition. And if you want to get the economics right, we have to build for scale. So it is going to be a bold step forward, but that's our view. As FTI, we have done quite a few of these feasibility studies in Europe in particular, for at project stage as well as for large enterprises. And I think that is where the Dr. Kasturi Rangan committee referred to it in 2016. The budgets were also put down. The intervention areas were really demarcated, but there's been not as much progress as we would have liked. Funding is the other big piece, which I think has been referred to in the discussion. Without funding into these large demonstration projects and, let's say, special purpose vehicles, which bring government and the private players together, it's going to be very difficult to get these off the ground. And we can't have just one or two. There has to be at least 5, 6, depending on the different use cases. Because this is going to be a long play. And I'll stop there because I think most of the people on the panel have heard this before.
Thanks Amrita for what we can say cooperating with me. I take the second quiz contest before I jump to the second track. The question is, H2E power promotes which technology? So I request all the delegates to type in there in the chat window, H2E power promotes which technology? So the delegates are busy typing their answers. I come back to the second track and I start with Amrit. Again, I'm reversing the order here. So Amrit, today we have had a news coverage where 5T hydrogen investment fund has come into place, and they are looking at euro 290 million to be dedicated. Out of that, 290 million has already been what we can say by different investors. They are looking at what we can say 1 billion kind of a fund. So how do we, and if you see this particular story, it says it will be focused on OECD countries. So how do we get this climate fund or climate change fund into India if we are looking at large demonstration projects that you were talking about? So your quick answer.
So I think we are at a unique moment where we can negotiate or have these discussions at a G2G level as well as with the multilateral agencies to have more climate funds flowed into India. It has been talked about from ambition standpoint. I think $10 billion has been talked about, but very little flows. So, we've had, John Kerry come into India. There are discussions going on at a G2G level with Europe, with Norway. Stoll is here on the panel as well. I think the use cases in India and the ambition make it very conducive for India to be able to sit with a sovereign to say, just as we have NIF, where Middle Eastern sovereign funds are coming together with India to create, let's say, logistics-based investment funds, we can do the same for hydrogen themed energy transition funds. It's possible to do. So that's what I think is an area for all stakeholders to come together in India and negotiate that at a multilateral agency level.
One small thing is which I wanted to know from you is these large demonstration projects. What would be the size and scale of this in terms of US dollar?
What we had put down was we should be aiming for at least $500 million fund by, let's say, 2025, right? We could start with a smaller amount now, let's say $100 million, but to start working towards something like at least $500 million. And as you rightly said, the 5T fund in which Chart Industries, who's also active in India, is a lead player. They are already looking at $1 billion. So unless India starts thinking in terms of those numbers that have to be raised as collectively, we will not be able to move to the next stage of commercialization, is our point of view. So I don't know if everybody on the panel is aware, Chart Industries, Reliance has come together to form the India Hydrogen Alliance. I think more industry players will join in. Funding is going to be a key hurdle, is our view.
Thanks, Amrit, for very candidly talking about the numbers, because these numbers will then help in industry collaboration, tie-ups, because this industry needs a lot of tie-ups so that finally we achieve the end result. Thank you, Amrit. Siddharth, briefly, I would now request, because we are paucity of time, we also have many questions, around 17 of them. So, Siddharth, if you can talk about the ecosystem and its readiness. Where do we stand and how do we move forward in a minute or so?
We are very interestingly poised in terms of the ecosystem. All the companies in the world are knocking to India's doors, but the Indian ecosystem, which is getting redundant, especially with the advent of the battery electric vehicles, all of these vendors are available and they have the expertise to build components that are required for the entire fuel cell chain, whether it is stationary or for mobility or for generation of hydrogen. And in our experience, we have got in touch and we've developed a lot of these people. It's a painstaking job, but I think this is something which is very important for India to do, to have a localized supply chain for every component.
So you were talking about you are looking at, say, this ecosystem within Pune for, say, electrolyzer kind of a technology that you are promoting. So how easy or difficult it is for that ecosystem to develop in India, and how cost effective it is?
Well, it took us 4 years. And like I said earlier, by 2022, almost 98% will be made here locally. And it's not only about the whole Atmanirbhar mission, which is very important, but I'm able to reduce the cost to a level where I will be able to make the cheapest electrolyzer with the best quality that is available anywhere in the world. So you also have a big export potential once you start building this.
Thank you, Siddharth. Now I come to Dr. Sushil Ramdasi, and if we can talk to him with respect to the potential segments that you foresee for early and successful implementation of hydrogen-based fuel cell technology. So, which, according to you, is the?
I think during my first round, I have touched upon it.
Yeah.
Potential segments to start with. Let's divide.
My second part would be, how do we indigenize it, sir?
Exactly, that's fine. So if you consider fuel cell electric vehicle as a whole technology, you have to split it into different parts. The first part, basically, you should consider as an electric drive. Basically, it's an electric vehicle itself. So a lot of opportunities are there in indigenization of electric drives. For example, induction motors. Let's go with a lightweight, high-speed induction motors. That is an opportunity for indigenization. Power electronics. Then coming back to the fuel cells, indigenization of the stack, right now it's a big question mark, but still I can say at least balance of plant associated with the fuel cell stack, that can be indigenized. There's a huge opportunity. This consists of like superchargers, blower pumps, humidifiers, hydrogen recirculation pump, and then coming to the next, which also I mentioned, hydrogen storage tanks, type 3 and type 4, typically 350 bar and 700 bar. There's a huge potential. Unless we indigenize it and we reduce the cost, capex cost, the business viability is not there. Because when we are formulating project proposals to fit the fuel cell electric vehicle within a 20 to 30% cost rise over the base EV is a big challenge. Because unless this challenge has been met, it's very difficult to penetrate the fuel cell technology on a large and mass scale.
Thank you, sir. DMR Panda, sir, if you can talk about, you talked about multiple things that NTPC is doing, but what kind of challenges that you are anticipating with respect to the different industry segments that you are catering to and the different solutions that you are catering to, and how do you plan to move ahead of these challenges and finally come up with a solution which is what cost friendly for everybody?
No, so the challenges are known to everyone. The point is how I can say, when we talk about mobility, hydrogen buses, can it come at par with diesel buses? When I talk about methanol or ammonia, can it come at par with traditional ammonia or methanol? And this comparison would always be there. But then there is a glimmer of hope. Few days back, we read from the paper that Tata Power is offering those who want renewable power they can give 60 odd paisa, say 66 paisa per unit, and they can have renewable power at their home. Now, those things once starts coming, probably at a residential level, at an individual level, there would be change. Supposing I a my phone or Apple phone, that is my personal decision. Now, what compelled me to go for an iPhone? The similar, can I take some pride in having less carbon emitting system for my own use? That is one aspect. The other is that can government do this? How long can government do this? And whether always the industry would be on crutches, like the funding arrangement. Now, if you take this slightly outside India, what other countries are doing? We have various models. Some countries, they say that this has to be funded, no funding. From the very first, this has to come up. Now, this is for the industries to figure out what will make sense. So we have various models. Whatever works, that is good. I'll only say that.
Thank you, sir. Dr. R.K. Malhotra ji, if you can talk about India's position to adopt hydrogen, and you have been a strong votary of blue hydrogen versus green hydrogen. So how do you see, where do we stand in terms of the position, sir?
So I said in my earlier speech also that we are here to have hydrogen supplied from refineries. We are ready. In fact, refineries have surplus hydrogen also, because when they planned for BS6, which was mentioned by Dr. Ramadasi last year, they have planned for hydrogen plants also. So I'm told most of the refineries are in a position to supply hydrogen as and when required at a reasonable price. That I said that distance of supply, transportation cost of hydrogen, etc., to be added, etc. So the point is that companies like Reliance, which have gone for huge petcoke gasification units, they also have large quantities of hydrogen. That's why they have joined that hydrogen coalition and all those kind of things. Indian Oil, all refineries spread all over the country can supply hydrogen. So to start with, you will have to depend on the supply chain of the oil industry. Then natural gas pipeline network is expanded. We will be able to have on-site reformers at various locations where hydrogen can be made available. So, and then this is all about hydrogen from the fossils. Even when my friend from Mtpc mentioned that they want to go all green, they will have, they can't dispense away. I don't partially agree with him that they will be able to stop all the thermal power generation in this country for the next 20 years. They cannot afford to do it. But nevertheless, whatever their plans would be, if the coal becomes surplus and they switch over entirely to green hydrogen, the coal gasification units, along with biomass, Siddharth mentioned about the biomass gasification and distributed power being made available. I think these are the ways that we can go about. And hydrogen can be made available. Only thing is we have to create demand centers. Now, the major issue at this point of time is the demand centers have to be created, the supply chain and distribution mechanism has to be created, and then ultimately, definitely the pricing compared to the others will also be there. And once the carbon pricing starts, I think that will also give a big push. But we can supply hydrogen. That's not a problem.
Dr. Malhotra, how do we create these demand centers?
Well, that is a bigger challenge. You know, we have to have this, like, you know, if you want to create for transportation sector, you asked this question also to the friend. I think that the electric vehicles is not a solution to heavy duty trucks and buses. When you want to convert long distance trucks, they have to be on hydrogen fuel cells. You know, you can't have a huge pack of batteries in the trucks and transport, because trucks are meant to carry loads. So either you will have to go to LNG or you will have to go to hydrogen fuel cells. And hydrogen fuel cells are more efficient. Now the costs are coming down. Toyota is very upbeat that the cost of their fuel cell vehicles will come down. So I think the demand centers like steel plants, if they have to use hydrogen, they have to be convinced that what are the benefits. And the pricing for carbon, some way we will have to say that you tax the carbon emissions, then automatically the demand will be created. environment tax or whatever form you want to put it. You will not have to subsidize hydrogen in that way. You particularly tax the carbon emissions, and then automatically people will switch over to hydrogen.
Thank you, sir. Now I request Mr. Girish Sethi. What kind of policy frameworks do you see, or the policy structures which needs to be built up for this economy to flourish?
Yeah, thanks. I think I'll not take much time. I think basically, many of these points on this subject have been touched upon by many of the earlier speakers, but I firmly believe that I think now is the time for the government to really push in very fast this whole effort on the hydrogen mission, really bringing in funds if required, whether from the domestic sources or from international avenues, for demonstration and pilot projects in all the areas, whether it is the blue hydrogen or the green hydrogen. And I personally believe, I think it has to be the use cases. I think Mr. Malhotra just now mentioned about, for example, you need to convince the users. Ultimately, it's the demand which is going to really drive the production. There is no issue really on the production. So to me, I think the entire emphasis at this stage has to be on demonstration pilot projects, on feasibility studies, detailed analysis for...
Yeah, please go ahead, sir.
Yeah, so I was basically saying that I think the entire emphasis at this stage has to be to support in the pre-feasibilities, feasibilities, detailed projects for pilots and demonstrations. And I am a big proponent of this whole thing that one need not sort of reinvent the wheel. You need to have these international collaborations, and for this, whatever work is happening in Europe on the use cases in different sectors, that needs to be brought to India through all the international mechanisms on the climate change which exist today. So some kind of a approaching all these international bodies like the Bank, World Bank, or even the Green Climate Fund. So today, because we are not talking about anything big in terms of RE, because the prices of RE have really come down quite a lot. So we are not talking about green financing from Green Climate Fund or things like that. But for these kind of technologies, which are new technologies, which in the use cases, there one can really think of approaching the international sources. So that's all at this stage. Thanks.
Thank you, Girishji. Now I come back to Sturle Harald Pedersen. And sir, the storage safety and environmental concerns with respect to hydrogen economy, and how do you address that?
Well, to do it very shortly, of course, everything starts with safety. With any accident, we know that we will have a very damaging effect on the public trust and investors' confidence. So to address safety in all the aspects of hydrogen is key. And it is also important, as I look at it, that you start to get the uniform safety standards and guidelines based upon best practices and international standards and codes. But it's also critical that we, to avoid red tape, keep in mind that we need to train and to educate the agencies, institutions, who is going to support and help the industry to developing the projects and the industry. So without that, I think that you will get a block that is really difficult to pass. And that's why this large pilot project is also important, because these pilot projects can also be used as vehicles or instruments in training and educating to make sure that everybody understands the whole value chain, so they know how to address it and how to support the industry, because this is a common work that we need to do. Nobody, as I say, coming back to all the time, we can't do this by ourselves. So safety is crucial, and it is important then to build this safety culture within India. and within the industry, within the public, and so forth. So I would say that start with education and focus on safety. You can just imagine that if you are building 10,000 filling stations, each of these filling stations would have a unique location with schools, kindergarten, hospitals, and so forth. And if we have an accident in one of these filling stations, it will really end the hydrogen journey, or at least it will delay it, and we will lose the train. So again, I will really emphasize that safety and understanding the risk involved is very important.
Thank you, sir. Now I request Mr. P.D. Samudra if he can throw light on how do we develop the hydrogen ecosystem. He has also some international learnings which he has been working with different companies through his company, ThyssenKrupp. So if you can talk about that. And after that, we will open up for Q&A. So over to Mr. P.D. Samudra.
Yeah, let me start saying that everything is valid what we said here. There is no competition between green hydrogen or blue hydrogen or fuel cells. All are important, and the country must go in all the direction. There is no way out. If you have to really reach the target of Paris Agreement, that is to reduce the emissions to 2005 level, then we have no option but to attack all the fields, number one. So number two, only thing, when you go for a blue hydrogen or gasification, you also emit CO2. So we have to keep that in mind. The gasification will not be the best option right now available. Thirdly, as one of the speakers said, you should not reinvent the wheel. The time is short. And all the international, if you see the development taking place, we seem to be circling in India on various options and various clusters formation, etc. But the world is moving differently. I just give example, the 14 nations worldwide already announced the plans for a concrete projects to be installed by 2030, amounting to 30 gigawatt capacity. If you look at the total electrolyzer power to be used for production of the green chemicals or the downstream units in European Union, Chile, and UK, it amounts to 75 gigawatt power. So gentlemen, please understand that the world is moving. In Denmark, there's a big mission going on for hydrogen. Already contracts have been awarded. Same thing happens in Norway. I think Mr. Sturle will also talk about it, and also in Italy. So basically, I just want to be saying openly that too much analysis can lead to paralysis. Let's focus on a project for each industry on the bigger scale, make the study, see the viability, come to the conclusion as fast as possible. The world is moving. We as ThyssenKrupp are in the business for the last 70 years in electrolysis. We have done something like, if I may tell you, that we have built about 600 plants with the alkaline water electrolysis, amounting to something like 10 gigawatt. We are right now engaged in doing the project for green hydrogen in Canada, in USA, in Australia, and in Germany and Saudi Arabia. So projects are really moving. It's a time we should really look at the project specifically and work on that individually. Thank you very much.
Thank you. Let me also take one quiz question and then we open it up for Q&A. I see around 29 questions which needs to be answered. The last question for the quiz is green hydrogen is made from dash sources. Green hydrogen is made from dash sources. So let me take the for Q&A. The first question is with respect to this is an anonymous attendee. As per Terry's green hydrogen report, 1,000 terawatt hours of electricity would be required for green hydrogen by 2050. Where will this electricity come from? So Girish ji, if you can answer this shortly, briefly.
I think when we are calling it green hydrogen, I think as per your question, this basically is referring to all the green sources. And primarily we have done the analysis based on the solar and the wind. So the details are there in the report as well for anybody to see. The entire analysis is on assuming that the electricity is going to come from renewable sources, which is solar and wind. So that is assumption.
Thank you, Girishji. Should the government also come out with a PLI scheme for electrolyzer? And I think the best person would be Mr. Siddharth or Mayur, who is developing solid oxide electrolyzer. So if he can respond.
Most certainly, if we want the whole green hydrogen story to be popular in this country, the PLI scheme is, I think, a must for the entire fuel cell value chain, whether it is making electrolyzers or making dispensing stations. But I think this is very significant and the government should take a note of that.
Yarasi Saujanya talks about any R&D on development of catalyst materials for SESMR has any scope in near future. Who will like to take this?
I think it was Dr. Lele's question. I don't see.
Dr. Lele
Mr. Malhotra can answer, but normally for SMR, the catalysts are well developed worldwide, and also we are Indian counterparts to supply that for normal hydrogen production, if possible.
So there is another question: electric vehicle versus hydrogen fuel automobile.
Yeah, I can take up that question.
Yeah, Mr. Ramdasi, sir.
Yeah. As I already mentioned, hydrogen vehicles, they are basically electric vehicles. Rather, using hydrogen fuel cell, you are going to extend the present range. So successfully, the studies have been demonstrated range extension by around 70 to 90% in case of heavy commercial vehicles, small commercial vehicles. And even that range is possible in case of even three-wheeler electric rickshaws. So I think with hydrogen electric vehicles, your dependency on the charging infrastructure can be reduced. Then the depth of discharge, you are controlling in a very narrow band. So whatever battery is there in the hydrogen electric vehicle, the life of that battery will get extended by 1.5 years to 2 years. So these are the major advantages with going with the hydrogen electric against electric vehicle.
Thank you, Mr. Ramdasi.
Can I pitch in here?
Yes, sir.
You know, it's not only the range extender, Mr. Ramdasi. Basically, you know, the battery size. You said the battery life will go up by 1.5 years. This battery, in fact, in a hydrogen fuel cell vehicle, the battery is much smaller.
Yes, sir.
Because you are driving the motor through the fuel cell, which is supplying the electric current rather than the battery.
Correct.
So the entire in an electric vehicle, the current is supplied by the battery.
Yeah.
So here it is not being supplied by the battery; it is being supplied by the fuel cell. The other thing is that when you do life cycle emissions, it has been found that in production of batteries, you emit a lot of carbon dioxide emissions. In a hydrogen fuel cell, when you develop the fuel cell vehicle, the overall life cycle cradle to wheels, the emissions are much lower, the greenhouse gas emissions or carbon dioxide emissions. So primarily the advantage is one, you said that you don't need charging infrastructure, the range is much longer, the fueling time is much smaller, the battery size is too small. It is basically the current coming from the fuel cell, not from the battery. So you said you were talking only about range extender, which is only one option of an electric vehicle. By putting a fuel cell, you extend the range, but otherwise the hydrogen fuel cell.
Otherwise, we can go with a full parallel fuel cell vehicle also.
I think I think range extender and the pure fuel cell vehicle is a little. Let us not confuse between the two.
Yeah.
Okay, sir. Ghanshyam Prasad Patel talks about this is with respect to Mr. Panda. The question is to Panda. Mr. Panda, India has used coal with high ash content. What Mtpc is considering is best to use for energy as our demand can be fully met by green energy? So, Mr. Panda. Mtpc has been focusing on green energy in a big way. And even if you see their statements, renewable is one which they are focusing definitely in a big way. And he also talked about in his presentation. Presently, he's there, but he's not able to take your question. So we can direct him later on. Then the question is with respect to Mr. Abhishek Amarnani. The focus is always on hydrogen. The focus is always on hydrogen in electrolysis. Can the oxygen also be used in some application? So, Mr. Sturle, can you answer this, sir?
Yeah, go ahead, Dr. Pedersen.
You are on mute,
You are
sir.
muted. You are muted.
Oh, this is your domain, so please go ahead.
No, we are actually doing a project in our lab where we are capturing the oxygen. And this idea, I think, came in with one of my discussions with Dr. Panda or at IOCL. Because of the COVID, there's a big shortage of oxygen cylinders. And also in the Leh region, a big shortage of oxygen. So what can we do with the oxygen that comes out? So we did some experiments in our lab and which were successful. But it is still early days to see, what exactly we can capture. But theoretically, yes, and practically it should be done.
Sir, Mr. P.D. Samudra, sir, one question from Mr. Ghanshyam Prasad and Patel. Explain alkaline water electrolysis role in hydrogen generation. And I understand Thyssen group have such technology.
Yeah, as you know, there are three technologies available for the electrolysis. One is alkaline water electrolysis, second is the proton exchange membrane, and third is high temperature electrolysis, HTL. So we are offering actually alkaline water electrolysis, which is using a KOH solution for the water electrolysis. And this has been practiced for last so many years, as I mentioned earlier, the production of caustic soda, caustic potash, and chlorine. So I can send more information on that if required. But all of the merits and demerits, this can be discussed separately. And
Mr. Kumaresh Mishra talks about what is the time frame we are looking at, and then the question is milestones. So when do we see commercial large-scale operations of, say, different use cases that we are talking in India with respect to the hydrogen economy?
I can take it.
Maybe.
Mr. Ramdasi, sir.
Yeah, as I already mentioned, a lot of work has been done on hydrogen storage, then transportation and formation. Now, in order to make it a proper, what I can say, a commercial solution, which is affordable, acceptable, and sustainable. So we have to bring down the cost of the fuel cell engine itself. Right now, the cost itself is around $500 per kilowatt. That has to come around $200 to $250 per kilowatt. In that case, if we want to use, as Dr. R.K. Malhotra said, the range extender is one part of fuel cell electric vehicle. If we keep on increasing the size of the fuel cell, then the size of the battery keep on reducing. But in that case, the cost of the vehicle goes enormously high. So in order to make a full parallel kind of fuel cell electric vehicle, the cost of the fuel cell stack or fuel cell engine and hydrogen storage has to be brought down. And when this will happen, I mentioned the range, for example, $200 to $250 per kilowatt. And hydrogen, as already mentioned, $2 per kg. Similarly, there are some targets for bringing down the cost of the hydrogen storage. If all these three works together, yes, then the demand centers can be created.
Thank you, sir. There is a Ayushi Prakash Sinha, as a PhD student from chemistry background. What can be our contribution for the hydrogen economy? Siddharth, if you can take that.
Come again, please. I missed that question.
As a PhD student from chemistry background, what can be our contribution for the hydrogen economy?
Well, you're in the most enviable place that one ever can be, a student of chemistry in the hydrogen world. I think learning more about how we can deal with hydrogen as a subject, the storage part, conversion into ammonia, conversion into other fuels. And in my organization, at least, I can tell you the chemical engineer is of very great value. I mean, there's one of the most valuable people in the organization. So for a PhD student, getting into the storage side and also into the other gases and fuels can be a very interesting topic to do your master thesis on.
With respect to, say, storage part of it, in conjunction with, for clusters for large power consumption. So, Mr. Samudra, if you can answer that with respect to hydrogen storage. Sir, you are unmuted.
No, yeah, sorry. You know, if you do in the gas form, it will not be of much use because the volume will be very high. On the other hand, if you want to liquefy, it about minus to 42 degrees centigrade, which is a very low, and we are going to spend money in the refrigeration to liquefy. Therefore, in my opinion, and from based on my experience, it is always good to have hydrogen source available near the industry, number one. Number two is in the vicinity about 15 kilometers, you can take hydrogen by gas pipeline. This is possible. But the best way is to convert hydrogen to ammonia or methanol and store it. Methanol preferably, because I still believe the transportation of methanol or by ammonia at minus 34 without ambient temperature is much better. And downstream in maybe 1,000 kilometers away, methanol can be used as a fuel directly. So I am not really sure whether hydrogen storage and handling will be cost effective, and also safety point of view, one has to be careful.
Thank you, sir. Amrit, if you can answer this part, what all agencies we can look for initial funding for green hydrogen demonstration projects?
There are quite a few climate funds that in Europe as well as in the US, and multilateral agencies. It's a full list. I think Girish mentioned some of them, but the European Investment Bank is a lead funder. We can probably share a list of all the funding agencies that are there. I can do that separately.
Thank you. There is a question for Mr. Puneet Dadich. For transporting hydrogen, why current natural gas infrastructure can't be used? In UK, H21 project is planning to convert existing natural gas infrastructure for 100% hydrogen transmission. So this question is with respect to the transportation of hydrogen. So I think this was answered partially by Mr. P.D. Samudra, sir.
No, but I think technically it is feasible. It is not a big issue. Only hydrogen has a problem of the pressures and the compressors, etc. As a light gas compared to natural gas, you require heavy duty compressors for doing it. But technically it's feasible. But how much distance you have to take from safety point of view? Because most of the pipelines are going through villages and towns. That you have to be careful a little bit.
I'm taking the last question.
Can I just clarify further on that transportation of hydrogen through natural gas pipelines?
Okay, sir.
Actually, the hydrogen transportation through the natural gas pipelines is one of the major issues. Is the embrittlement of steel. So I think till such time that's an issue. You will have to have new kind of pipelines. Otherwise, you can blend up to 18 to 20% of hydrogen safely in natural gas pipelines. But you can't transport 100% hydrogen. One is it's not only a question of pressure, but it's a embrittlement of the steel pipes is a issue, another issue, which is very
critical. And there have been fires reported with embrittlement. It's very
embrittlement can damage the pipelines.
Absolutely.
So,
correct.
So that's the issue.
I think that also what is referred to is a mixture of hydrogen with the natural gas, and then they split it up at the end application point.
Yeah,
so, you are right. You can mix the hydrogen with natural gas and then separate it, and then use hydrogen. So that's a way. But you can't blend more than 18 to 20% of hydrogen in the natural gas pipeline.
I'm taking the last question. Mr. Kailash Lathard. He is talking about, and this is for Mr. Susil Ramdasi, how safe it is to use hydrogen fuel cell in vehicle with respect to accident, and do it needs maintenance?
Rather, I will say hydrogen has got a wider flammability limits, and the hydrogen is a lighter. So I can say it is as safe, rather more safe than any gasoline vehicle.
So with this, I would like to thank all our speakers. Mr. P.D. Samudra, CEO and MD, Thyssen Group, Industrial Solutions, India. Mr. Sturle Harald Pedersen, Chairman, Greenstat Hydrogen India. Dr. Ashish Lele, Director, CSIR, National Chemical Laboratory. Mr. Girish Sethi, Senior Fellow and Program Director, TERI. Dr. R.K. Malhotra, Director General, FIPI. Mr. DMR Panda, GM Hydrogen Mtpc. Dr. Susil S. Ramdasi, Deputy Director, ARAI. Mr. Siddharth R. Mayur, founder, H2E Power Systems. Mr. Amrit Singh Dev, Senior Managing Director, FTI Consulting. Let me thank on behalf of ICN, Indian Chemical News, as well as on behalf of all the delegates present in this e-conference. I would request all delegates to rank this e-conference on the chat window. I see 175 people still there. So I would request all delegates to rank this e-conference on the chat window, 1 being the lowest and 5 being the highest. So I would request you to please rank so that it is useful for us to have a feedback mechanism. And the best thing is that to get feedback mechanism without any delay, so that we can improve on it going forward.
On behalf of panelists, we would like to thank Mr. Praveen Prashant for excellent conduct of the meeting here.
I would like to thank all my speakers who took time out and have extended their time. I had given them 4:30. They are here for 120 minutes. So I would also like to thank all my speakers for being there and cooperating with us and answering all the queries of my delegates and helping me in this endeavor. Thank you, sir, for this gesture.
Thank you very much. Thank you all of you.
Thank you.
Let me announce the winners of the ICN
Thank you very much, everyone.
Let me take one more minute, sir. The winners are, the first question was with respect to investment in hydrogen economy will reach $300 billion by 2030. And the winner is Mr. Mrigendra Rai, managers Statcraft, Delhi. Then the second was with respect to H2E power promotes which technology? The answer is solid oxide electrolyzer. And the answer is, the winner is Shruti Kumari, energy analyst, Panitech Power AG Pilani. And the third was with respect to the hydrogen part. And the answer and the winner is Mr. Harjeet Anand, Joint Director Technical, AMI, Delhi. So I would request, I would thank all the delegates who have won this contest, ICN Play and Whiz contest. I would request all delegates to register for the next set of events. We have on April 20, role of women in the growth of Indian chemical industry. April 23, outlook and opportunities for the gas sector in India. April 21, 28, improving engineers with advanced analytics. May 18, Indian specialty chemicals opportunities galore. May 21, green chemistry sustainability challenges and opportunities. Let me thank all my delegates as well as speakers once again, and all the delegates who registered and also participated in this event. Those who have not been able to participate can look to our website tomorrow morning, and they can have the recorded video for them on our website. Thank you all. This is Praveen Prashant signing off to meet you again April 28th at 2:55 p.m. Indian Standard Time. Thank you all.
Okay, thank you.
Thank you.